Welcome to the Tech Egg. Don't get scrambled. Enjoy the video.
You start by preparing the project. Open Android Studio and create a Kotlin app with a foreground service and microphone permission. Next, add dependencies for speech recognition, ML kit models, TF-Lite, and retrofit for APIs. Once done, scaffold a service that captures audio chunks and a simple view model to manage state. Make sure to request runtime audio and network permissions at first launch and test microphone access. This gets you into the development loop immediately, so you can build the Jarvis core. Now implement the pipeline. Stream audio in small frames to the speech-to-text engine and forward transcripts to your intent parser. You should use a lightweight NLP library or a custom regex intent mapper to translate text into actions like play music or control EOT. Once you have intents, route them through a command handler that uses retrofit for web APIs and TF-Lite for on-device classification. Make sure to debounce repeated triggers and log inputs to refine confidence thresholds during testing. Finish by creating a minimal UI with a hot word toggle, real-time logs, and action cards for feedback. Integrate with system services, notifications for the foreground service, work manager for scheduled tasks, and secure storage for API keys. Once integrated, optimize battery use with proper wake locks and reduce sample rate when idle. If things go wrong, check microphone permission, confirm foreground service notification, and enable verbose logs. One key tip is to validate audio capture with a separate recorder to rule out hardware.
Thanks for watching. Consider subscribing if I helped unscramble your problems.